All right, study guide part 2. So for this, I'm going to try and do my best to hit a problem in each section. Keep it simple. This section here, 30 to 32. 30, 60, 90 triangles. How do we know? Number 1, we get a 30-degree angle or a 60-degree angle. Number 2, it tells us 30, 60. So at that case, I'm going to just pick a random one. I'll probably pick the middle one because it seems to be the hardest. I'm going to label it according to my algebraic terms. Short leg is x, long leg is x squared to 3, up here x squared to 3, and the hypotenuse is 2x. Okay? Just labeled the wrong side, so 2x. I'll use red, it'll show up a little bit better. You have to look at the problem and understand a couple of things. B is also the short leg, so B and x are the same thing. So if I find x, I know B. A is the hypotenuse, so if I find the hypotenuse, I also know A. So pay attention to what I'm going to do. Yes, I'm going to go through this quickly, but I'm going to show my work. It wants me to find A and it wants me to find B. Don't necessarily have to do that in order. I do know the long leg is 11 rad 3, and 11 rad 3 is equal to x times the square root of 3. Right? Think about that. They're equal to each other. So if they're equal to each other, I'm going to set them equal to each other, and I'm going to solve for x. X is equal to 11. All right? If x is equal to 11, b is equal to 11. X and b are the same. A, how do I find A? Well, I know A, different problem here. I know A is equal to 2 times x. Do I know what x is? Sure, I solve for x. A is equal to 2 times 11. Remember, parentheses mean substitution, or A is equal to 22. Or 22, not 20. 22. There you go. In the next section, they're just asking you to create the ratios based on where you start from. So 33, you start at x. If x is my starting point, first thing I default to is hypotenuse. So that means 35 is opposite, 12 is adjacent. It wants the sine ratio. The sine of x is opposite over hypotenuse. So 35 over 37. I'm done. You do the same with cosine and tangent. Same with problem 34. Down in here, you need to find the missing sides, 35, 36, and 37. That is a trig function. If you pay attention to 36, it's one of your special ones. 35 here, I start at A because I know that angle. 4 is opposite. It's a leg opposite. X is adjacent, so that's going to be a tangent of 41 is equal to 4 over x, right? And when we get x, we swap. So showing my work, and I don't have room down here, so I'm going to move it over this way. When I swap, x is equal to 4 divided by the sine of 41. Plug that into your calculator, get the answer, okay? Or find the decimal equivalent of sine of 41 in your trig chart. 4 divided by that decimal, and that should give you the answer. Make sure your answer's legit. Your answer is going to be somewhere around 4. I can tell you that because that's a 41-degree angle. If it was 45, the legs would both be the same, right? 38, they're asking you to find a degree. 39, 40, same thing. My degree is my variable. From the degree, opposite and adjacent is what I know, so that is a tangent function. Tangent of x is opposite, 27, over adjacent, which is 38. And how do we get rid of the tangent to get the x by itself? Multiply by the tangent inverse. A lot of you are showing this work and trying to tell me that x equals an answer. Yeah. No, you need to show your work. Come on. X is equal to, because those cancel out, the tangent inverse of 27 divided by 38. Now you can say x is equal to. All right? Now we move on. 41, 42. Solve each right triangle. There are multiple examples in your book solving right triangles, finding the angles, finding the sides. I will tell you, you can Pythag to find BC. So BC is a leg. So BC squared plus 17 squared is equal to 18 squared. And if you do the math, BC is equal to, what was it? I think BC was equal to 6, if I remember correctly. All right? Now, in order to find A or B, that's a trig function. If I want to find A, okay, A is my starting point. At that point, I would use opposite, which is 6 over 18. I'm going to use the cosine ratio because they give me adjacent and they give me hypotenuse. So the cosine of x is going to be equivalent to 17 over 18. Inverse trig. It's an inverse trig problem, right? So get rid of cosine and you know your answer. At that point, it's just like what we did up here in 38. 43 and 44, you have multiple examples in your book on that as well. They give you the diagram. You don't have to draw it. It's already there. You should know how to do that. That's repetitive. 45, 46, 47, and I'm not going to cover 48. 46, draw a triangle. Label that C. Find A, B, doesn't matter. It's your triangle. You could flip-flop A and B. If I make my triangle like this, the cosine of my angle B is equal to adjacent over hypotenuse. So the adjacent leg is 3, the hypotenuse is 5. Find all of your angles, all of your sides. Pythag to find AC, or you could use trig. You could make that X. Okay? I'm going to make this angle A, this angle B, and make that X. All right? So you can Pythag to find X, or you can do trig to find X, either or. There is the rest of your study guide in a nutshell. I know that's quick.